I have to say, that is the coolest intro.
I know, right? That's pretty awesome. Well, welcome everyone to another edition of ECS Workshop. I'm Brent Langston, and we also have
Adam Keller.
Right on. Adam, introduce yourself.
So thanks, Brent. My name's Adam Keller. I'm a developer advocate on the containers services team here at AWS. So I talk all things containers at AWS, modern application development. DevOps is a big hot button for me. But I love talking anything that's just progressive and how we can just live a life where we build cool things, but we get to sleep through the night. That's my goal in life.
I like that. I'm Brent Langston. I'm also a developer advocate, and I just want to echo everything that Adam just said. Especially the sleep through the night part, because I have lived on PagerDuty, waking me up for years. And so it's so nice to sort of walk into or build an environment where that doesn't really happen. So yeah, Adam has heard me talk about in the past the 3 a.m. rule. So we want to try and reduce the amount of alerts and stuff that comes up for you by showing you how to build great infrastructure.
Yes, and I think you'll hear a common theme, especially today. So obviously, today we're going to be walking through a migration scenario, and you'll hear a common theme where Brent and I will talk about tooling that's opinionated, and whenever possible, if I have an option to use a tool that's built by AWS, that's maintained by AWS, that builds on recommended practices and takes a lot of the kind of boilerplate off of my hands, I'm there every time. If I can do it, I want to take advantage of that. So you'll hear that as a common theme, and it just goes back to the 3 a.m. rule. Is Brett and I are always thinking, how can we help our customers not have to wake up at 3 a.m. and be like, oh my goodness, where do I start? What happened, right? We want to help you to build resilient, secure environments in AWS.
Nice.
So let's quick overview. So this is we're going to do this migration workshop today. This is a part of the Amazon ECS workshop, which is available at ecsworkshop.com. So if you want to follow along with us, head to ecsworkshop.com. And by the way, this is not a limited appearance. ecsworkshop.com is up 24 hours a day, 7 days a week. So it's always available for you.
It's going to be there forever. And I say that with a touch of sarcasm because obviously nothing is forever, but we have no plans to ever remove this. So yeah, this is here. So share it with your colleagues, take it with you to the next place that you work. It's constantly evolving and improving and stuff like that. So yeah, check out ecsworkshop.com anytime you have questions about ECS.
Yes. And yeah, so we're continuously adding new chapters, and the newest chapter we added for this workshop was migrating workloads to ECS. So before we get started, it's recommended that you start with a fresh AWS account if you can, or if you're using an AWS account that is used, with a team or somewhere in your organization, just make sure you're not playing around in a production account, with production resources. So
fair, good point.
I like to say that just in case, you never know. So to start the workshop, we're actually going to we'll talk a little bit about Amazon ECS in a little bit, but if you want to dive into just what is Amazon ECS, what is AWS Fargate, and some of the concepts, there's an introduction section here that goes over containers, talks about ECS, all the integrations that we have built in with other AWS services. So I highly recommend you read through this when you have a chance. But to start the workshop today, we're going to build a Cloud9 workspace. So a Cloud9 is a cloud-based IDE. So it's in your AWS account. This is an IDE that's in your web browser. And it's basically behind the scenes running on an EC2 instance. But all you do is we'll walk through this, and you'll see by the time we walk through this, we're done with this section, we'll have an IDE in the cloud ready to go for us to do our testing. So we're going to start, oops, let me go back. We're going to start by logging into the AWS console, and we're going to click this link to create a Cloud9 environment. We should open this in a new tab. I just realized it opens in the same feature request. So, and we're gonna follow the steps here. And by the way, I think it was mentioned before, but if you have any questions as we're going through the workshop, we're here to answer those questions. This is live. This is not recorded. I'm not a robot. So we're here to talk through any questions you may have as we're building this out. So we're going to click Create Environment. We're going to name it ECS Workshop. We're going to stick with the defaults. So we're going to stick with the T2 micro. This is free tier eligible. Leave all the default settings as is. We're going to hit next step, and then we're going to create environment. So this takes maybe a minute or two, but again, this is going to build an interactive development environment in AWS in my account that I can access and use for my application development, my infrastructure development. Everything I want to do within my AWS environment, I can do it here. So while this takes a moment, I'm going to scroll down here. So once it comes up, you'll close these tabs, and then we'll open up a new tab, and we're just going to have one terminal that we're going to work with in the console here. And you have the option if you want to mess with, the themes, you can do that as well. Also, if you have a preferred editor, I personally like Vim. So, and like I can't break from Vim. I'm just stuck with Vim for the rest of my life, I think. But if you like, I think Nano or I think there's other editors too. You can choose your default editor when you're working in the IDE as well. So if you like those key bindings, you can stick with them.
I like Vim key bindings.
I do too. I'm hooked. Like sometimes I get caught in a Nano terminal, and I my brain literally breaks.
Yeah, man.
So, okay, so I closed all those tabs, and I clicked here on the plus button, and I just clicked new terminal. So really quick for me, because my my username is pretty crazy. We're just going to change this. You don't have to do this. Okay, so there we go. Okay, so we have our IDE. It's up and running. And you can see this is a Linux instance. Like anything in AWS, it doesn't have access to resources by default, right? Security is job 0. So the only access is what we grant to this. So let's move on to the next step, where we're going to actually create an Iam role now that we're going to attach to this instance. And we're going to give this instance administrator access, because we are going to be building a lot of things in this workshop. So again, this is why I just mentioned, if you're in an account that doesn't have, that's like a production account, you don't have that level of access, I definitely recommend using a fresh account for this, or using an account where you have access to you can get administrator access. Okay, so we're going to stick with, just follow that link and you stick with the defaults. We're just going to name it ECS Workshop Admin, which I already have one created. So I'm going to leave that as is, but you'll just click Create Role, and it's going to take you to that role. Just make sure you name it exactly this, because in a few steps, you'll see why. Okay, so we have our Iam role. Now we need to attach this role to our Cloud9 instance. So again, you just follow this deep link. This is going to take us to that EC2 instance. And what we're going to do is click actions, security, modify IAM role. We'll find our role, which is ECS Workshop Admin, and then we're going to click Save. So quick, 30-second overview with in AWS identity and access management. This is how you control your access between AWS services and resources. So what we're doing is we're taking an EC2 instance and we are attaching an IAM role that says we have administrator access to that instance, which essentially will give that instance administrator access. So if we're using the AWS CLI, AWS SDK, anything that uses the credential chain to log in and get that access, you'll be able to do right on the host. So I don't need to have keys sitting around on my instance. I don't like that. I avoid keys wherever possible.
So for what it's worth, I've had a couple questions about Cloud9. And I know you were talking about it a second ago, but let me just try and answer these directly. Someone asks, what is Cloud9? It's a web-based IDE. And what's cool about it is it's running as an EC2 instance in your environment. So you can drop in into your own VPC and have access at that VPC level to all the resources that can get into that VPC. And then the second question is, Cloud9 is a free offering, correct? And like everything at AWS, pricing is complex. So Cloud9, the service is free, but it's going to bring up an EC2 instance, and that EC2 instance might have a charge. It depends on how you size it and what resources you attach to it. So just be aware of that. But one of the cool things that Cloud9 does is it manages the state of the EC2 instance. So if you close out, leave, then by default, after 30 minutes, Cloud9 is going to put that EC2 instance to sleep, and you'll stop paying for the compute and memory, the CPU and memory portion, and you'll only be left with, I think if you have an EBS volume attached, you'll be paying for the storage. Yeah, so that's pretty nice.
Yeah, that's super nice. I forgot to mention that. That's such a great point. It's one of my favorite features. It just shuts off when I'm not using it.
Yeah,
it really
totally.
kind of fits into the pay for what you use model.
Yeah.
And so I did go to preferences after I attached the IAM role. I went back to the IDE and I just went to our preferences, AWS settings, and I'm just turning off AWS managed temporary credentials. Basically, just this feature is a way for Cloud9 will actually dynamically continuously rotate and create new credentials. But with what we're doing, we have some long running processes. They could time out because of that. So that's why we uncheck that feature. Okay. So we're going to just install some prerequisites. I'm going to run through this, but essentially what we're doing is we're just setting our region as an environment variable. We're configuring the AWS CLI because we will have some interaction with AWS CLI. And then we're just going to confirm that it works. And then the last step is we're going to just expand the storage on the instance. Comes with 10 gigs. I've just found that, we can run out pretty quickly. So that's what I'm going to run through right now. So I'm going to install JQ. This is a way to parse JSON. JQ is super fantastic if you've never used it. It's a great way to programmatically sift through giant JSON blobs, or just to have really pretty JSON output as well. I'm a fan of pretty. Okay. So we've added the credentials. We're going to run this here. This is going to tell us, yes. So our region is set. So this is good. You want to make sure that when you get to this point, your region is good. And then if it's not, just go back up and check what happened in these steps. And then we're just going to configure the AWS CLI. And then we're just going to validate that our IAM role is the role that we attach to the instance. So you can see we basically, through the CLI, we're just checking what is our role, who am I when I make this call to the AWS APIs. And then we're going to run this script here. So this is going to install Boto 3, which is the SDK for Python, and then it's just going to expand the disk and then reboot the instance. So this will take probably 45 seconds to a minute, and then you'll have your terminal back up. Sometimes the terminal may hang, so just close it and then create a new terminal. So that's it for creating the workspace. This is, if you're following along with us, again, the workshop is built in a way where we expect you to be building in Cloud9. It's not to say that you can't do this if you're using Visual Studio or iTerm or your own terminal, but just keep that in mind that we have some expectations here that you're using Cloud9 as we go through the workshop. We're going to say something, Brent?
Yeah, I was actually just going to say you're answering for someone else in chat asked slightly differently. Can we run and access via on-premise? And so I assume that's what they're asking is, could we do this like using our laptop or something like that? And the answer is yes. You'll probably have to adapt some of these instructions slightly for your particular operating system or whatever. But for the most part, yes. We're just trying to show you how to connect in and talk to the AWS APIs. And the most consistent way that we can do that is to use Cloud9. But if you want to adapt, then feel free.
Yeah. Perfect. Yes. Yeah, this just gives us that consistent experience. So when we host large workshops like this, everyone has a different workspace. And also, this is another benefit of containers, which we'll talk about in a little bit, right? But one person could have a completely different setup than the other, and they could have two very different issues. So makes things a lot simpler. Okay, so now I'd like to get into the workshop. So what we're going to do is we're going to go to the migrating workloads to ECS chapter. And so what we're going to do today in this workshop is we're going to migrate an API service. This API service, it's running on a virtual machine, which is Amazon EC2. And we're going to take that and we're going to migrate it to a containerized workflow. And then we're going to get that container up and running in a production-ready environment hosted on Amazon ECS. So the API service, this is to kind of paint a little context here. This is I'm going to start here, actually, meet the application. So it's a REST API. It's the user service. So this service is responsible for managing and basically updating, responding to other services with information about the users in this larger system. It's written in Python. We're using Fast API, and to model our DynamoDB table, which our database here is DynamoDB. So the way we model and talk to Dynamo is through another open source project called PynamoDB. And
Dynamo.
Isn't that cool?
Yeah, that's pretty funny.
And so what we're going to do is, in this simulated migration, is we're going to consider what it takes to migrate an application that exists in a larger ecosystem and all the different thoughts that you have to have as you migrate. And we're going to walk through what that takes to get you from running your application on a virtual machine to a container. So with that, we're going to start with installing some prerequisites. So we're going to clone a repository and then install some tools. We'll install the AWS Cdk. You'll see why in a few moments. And I'll explain what the AWS Cdk is in a few moments if you're not familiar. Well, we're going to install AWS Copilot as well. So the tool that we're going to use to build and deploy our environments and our containers to ECS is AWS Copilot, which, again, we'll dive into that in just a little bit. So going back to my terminal here in the IDE, I just copied all of this. So there's these little copy buttons. So you can just click that copy, and then I pasted it into my terminal. So just keep an eye as it's going through. If you see any issues, definitely look through, reach out if you have any questions. But this is just kind of boilerplate stuff. We're installing some plugins and some tools. Okay, so we're good. So everything looks good here. So now what we're going to do is regarding the applications, if you're interested in actually seeing the code, there is that GitHub repo that you cloned, but also there's a code review section here where you can dive into the code and see exactly what we're doing.
Nice.
But just to give you a high level, you can see here's our API. Basically, we have these different endpoints. You can get all users. You can query specific users. There's a health check endpoint, as well as a load database endpoint. And so obviously, in a production environment, you're probably not going to have a load database endpoint, but for a workshop, it makes things a lot easier. So you don't have to, deal with any of that.
Someone in chat has already complimented you on an earlier script that you were showing and how environment variables are getting set and stuff like that. So
nice. Yeah,
you're getting some accolades in your community code review.
This is a community code review. Thank you. I got to say that's the nicest code review I've ever received. So thank you for that. I appreciate that. I mean, look, nothing's perfect, but we try to do what we can. So if you wanted to run this on your instance, which maybe I'll do that. What the heck?
We're going off script.
Going off script. We're doing it live, Brent. We don't have the doing it live banner.
That's right.
So if I navigate to the app directory and I copy and paste what I did. So I'm going to create a virtual environment. This is a way for me to install my Python packages locally to that directory, so I don't have to worry about any global issues. I'm going to install the packages, and then I'm just going to run the app. So you can see here, my app is running on my machine. And if I open up a new terminal, I curl localhost 8080 health. There it is. It works.
Nice.
Now, if I tried to talk to my users database, I'd get an internal server error. That's because it doesn't exist.
Yeah.
Right. There's no table right now. So that was it. If you wanted to just run it and see what that's like. Now, we'll get into this, but just keep in mind, like, this workflow is really great if it's my workstation and it's just me building an app and I control everything. But as we start to talk about containers and some of the benefits, just keep in mind, if I have Python 3.7 installed on my machine, Brent maybe has Python 3.9 or Python 2.7, because he's just a maverick. Well,
Python 2 forever.
we may have different experiences. So that's just one of the challenges when you're developing software. You have to think about these things, not just on your machine, but where they're going to live beyond your workstation. So, okay, that's the app. Enough there. But if you do have any questions, glad to talk. Also, by the way, you can reach out to Brent and myself on Twitter at any time. If you have any questions after the workshop, we love to chat with folks about ECS. And I'm at Real Adam J. Keller, and he is at Brent Contained, which is the coolest name ever. Okay, so here's what we're going to do right now. We're going to build our original environment. So this is like, our legacy environment. I don't mean that in a negative way. But basically, when I say legacy in the context of this workshop, legacy just means our environment we want to migrate from to our new environment. So we're going to just copy this command, and I would recommend just running through that and just pasting it and letting it go. And let's just talk about, while we wait for it to build, what it's actually building. So it's funny because we're building a legacy old environment in a very progressive way.
It's true.
We're using the AWS Cdk, which is the cloud development kit. So the AWS Cdk is a way to provision your environments in AWS, your resources as code. And when I say code, it's Python, TypeScript, JavaScript, .NET, Go, Java. And this is a way to declare infrastructure programmatically. So the AWS Cdk has been around for, I want to say, I don't know, a year and a half, 2 years. I've been following the project since it was a baby, since it first started, and it's grown a long way. It's open source. So if you ever want to check it out, it's on GitHub. You can see the roadmap, the progress we're making on the tool. But let's look at what that actually the code looks like. So one of the benefits of the CDK is you can take advantage of higher level constructs. So a construct is essentially a way to define one or many resources in one package. So an example of that here is I'm building a VPC. To build a VPC normally, or actually, let me put it this way. This one line of code generates many lines of CloudFormation.
I think, didn't we count at one point? It was like 500 plus, and then the count of individual resources that you would have to go and build yourself it's dozens that you would have to go and configure because, well, I feel like you were about to actually run down a list of stuff that this builds for us.
Yeah, but that, Brent, whenever you want, please chime in.
I don't want to steal your thunder, but I mean, I've built a VPC. I feel like I'm an expert. But no, you have to, I mean, if you think about it, you want to be multi-availability zone. So you have more than one of those. You start off assigning a subnet, and then you break that subnet apart into smaller subnets. And you assign those to typically public usage and private usage. You build a security group, you build a NAT gateway for your private subnets, you build an internet gateway to be able to get your traffic in and out of the VPC. I mean, there's just so many things that you have to do, and you have to get it all right. And yeah, it's a lot, and I've gotten it wrong a lot. So so having just one quick line that says, build me a VPC the best practices way is fantastic, because I've spent hours doing it by hand early on in my career and gotten it wrong so many times and had to troubleshoot. Like, I don't know if any of you out there have ever gotten a net mask wrong, but if you typo a net mask, then troubleshooting that can be like utter chaos, because traffic works one way but doesn't work the other way, and you're just pulling your hair out wondering why. So anyway.
Yeah, and one thing that I always like to talk about in addition is route tables too, is configuring these routes and making sure I've had issues where I misconfigured a route table. So, actually, it wasn't me. I misconfigured a lot of things. This one wasn't me. So when I tried to find out what the issue was, it took a long time because it was hard to, I didn't really, there's just so many components. So yes, so this builds a lot. Now, the other great thing about the CDK is it's super powerful. So I can, if I need to be an expert, I can be, and I can actually expand upon the constructs and configure as I need. So we build a VPC. We're building our database, which is a DynamoDB NoSQL database. And the way we're configuring our application, so we saw our Python API. So this app is running as a systemd unit. So we're using systemctl. Is it system control or systemctl? I never know.
I say system control, but I also say kube control, and I say I don't say IO control. I do say ioctl, but that's the only one that I kind of deviate from when it comes to the controls.
All right, so we're going to say system control. So it's a system control unit, and essentially that's how we're controlling it. So whenever, this is just general advice, and I know Brent would agree with this. Whenever we're building an AWS, so when you're building an AWS, think about ways that you can automate. You don't want to be manually configuring anything. Of course, there's exceptions to every rule, and there's going to be times where you just can't, you can't avoid it. But this is an example of, we're taking our service configuration, which is a systemd unit, we're wrapping it into a user data script. So user data essentially is a way for you to package a script or a set of scripts or whatever configurations you want to happen on that EC2 instance when it comes up. And it will run that automation when it starts. So what we're doing is we're creating our systemd unit and we're starting our user API service. And the way this all works is it sits behind an auto scaling group. So if we needed to scale out, we could build our own auto scaling if we wanted to. but I'm just having it sit behind an auto scaling group, which means it's controlled by an auto scaling group. If my EC2 instance dies, the auto scaling group will recognize that and bring up a new one to replace it. So we're building automation that if something does happen, I'm sleeping at 3 a.m. and the auto scaling group is waking up at 3 a.m. to take care of that for me.
And it can do it way faster than I can do it at 3 a.m.
That's absolutely true. So
we
any other questions?
Yeah, we had a question come in a minute ago. First, people are recognizing that, building VPCs is annoyingly hard. So yeah, that's awesome. But how do you customize the CIDR range, route table, basically all the VPC settings? And I answered it, but maybe you want to, talk about how you can pass stuff into the construct. You don't necessarily have to show us.
Yeah, absolutely. I'll just do a quick Google search here.
There you go.
I like. So you can, so the construct has these kind of basic parameters you can pass in. So I can pass in a CIDR range. I can specify subnet types, but all these options are here. So basically there's parameters. I just pass in what I want to those parameters. So if it's just a CIDR block that you want to pass in and you want to let the CDK handle distribution of ranges between subnets, simply pass in your CIDR block like this. That's it. Nice. It's that easy. But yes, so this would be where you go. And I would recommend the CDK documentation, super powerful. Again, it's an open source project that AWS builds and manages, but we can always improve. So if you see something that you don't like in there, submit an issue on GitHub. The team will always take a look and respond. But anyway, so short answer is this is how you would expand.
Nice. Thank you.
Yeah, good question. Okay, so our environment's done. So what I want to do at this point is I just want to validate that our legacy environment works, right? And our application works as we expect. So what I'm going to do here is I'm going to grab the instance ID, and then I'm going to start a shell onto that host. If you haven't heard of Session Manager, and by the way, I know we're just mentioning a lot of services, a lot of tools. So again, it can be overwhelming. So, get that notepad out, start taking notes. But again, you can reach out to us on Twitter. We can chat anytime. But if you haven't heard of Session Manager, it's essentially a way to open up a shell into your hosts and ECS tasks, by the way, without having to open up SSH, having to have the SSH port open on your host publicly, or having to think about all that. You can keep the ports closed. You keep that, you're not enabling any access through security group, and it's all done through Session Manager, which is managed behind the scenes, encrypted, et cetera, et cetera. So let's execute that shell now. So I'm going to just copy that command. And again, we're grabbing the instance ID, and then we're just entering a shell onto our host. So you can see, I wonder, sudo yum install -y htop. So we could just see, this is my operating system, my host, it's running, my virtual machine, there it is, right? Let's confirm that our service is working as we expect, right?
So just like you did when you tested it locally, now you can test it on that instance. Nice. Exactly.
Status user, it's API? Yeah, so look, here's my system control unit running. I'm going to say systemctl, sorry.
That's fine.
So here it is running. I can see logs as it, so if I do -l, I can see, remember that health check I ran? Perfect, it's logging. This is amazing. Our app is working. So this is our chance now. Let's load the database. And this also will confirm if our access to the database is correct. Status success. So great news. We were able to load the database. So if you're at this point, you should now have an environment that's up and running. Your application's good. We're ready to start talking migration. But just, if you want to test the application, if you're a fan of a certain show, I just happen to load the database with the user database with certain users. But anyways,
this is awesome. I rewatched that show during lockdown, and it was it was pretty great to rewatch. It definitely holds up.
I gotta tell you, I had never seen it, and just the past like month and a half, my wife and I've been watching this, and
Awesome.
we love it. So
awesome.
Anyways, yeah, it's Big Bang Theory. Anyways. So
I like how we were talking about it like it was a secret.
Yeah, that's the show. I just wanted to have that inside, group, but I don't want to exclude anyone. So anyways, so that's it. So you can see I can query the application. You can see I just queried localhost, the user, first name Sheldon, last name Cooper. Here's his information. So our app is functioning. Everything's working. So I guess let's take a moment to pause and talk about our environment and how it runs and kind of the management that goes into this. So yes, my application's working. I think we've built it in a way that's pretty solid, that we can tolerate if the instance goes away, if we can scale out EC2 instances, but there's still challenges here. If I want to co-locate this application with other applications on this host, I have to think about, if I patch an instance, if I upgrade a version of the software that I'm using, how does it affect all these different applications, right? Go ahead.
Oh yeah, no, you're definitely you're resonating with me, because I've lived through this pain. And another one, a lot, even if you can work through all of that magic, and get 2 or even 3 applications to coexist. The other thing that you then run into, though, is when you try and scale, you have to scale all of them together. And, you're going to have to sort of figure out what is the lowest common denominator that you can live with for all 3 of these applications. And the fact is, it doesn't have to be that way anymore. Like we've moved past this. And I've like in my head started 3 different sentences all at once. Before containers, we had this relationship of application to instance, or if you're in a data center, application to server. And if there was one application for one server, and you would just make more of them. So you would set in your, in Chef or Puppet, you would set the type of instance that server is going to be, and it would come up and it would install all the right stuff. Trying to merge those together and support 2 applications is extremely difficult. Trying to then scale is extremely difficult. When you put the stuff into a container, then that becomes a single unit, a single artifact, and you can drop it in anywhere that you can run compute. And so these things can all coexist together very easily, and you abstract away the need to think about personalities for all the different servers. They're just servers at that point, and all they're going to do is run a container, and it doesn't matter what's in the container because it can run it. Well, that's my 2 cents.
I love that. Yeah, I mean, it's because there's so much to think about when you're running these servers. And even if it's the one-to-one mapping. I have one application on one server, and then I can then think about scaling those servers. It's still, I'm a developer, I'm working on Python 3.6, but the server's running Python 3.7. Or, right, there's just so many discrepancies. It's hard to keep track of all that. And I can't tell you how many times in my career I've worked with development teams, and that was what I heard, right? It was, I'm using this version of Ruby. It works on my laptop.
Right.
So with Docker and with containers, one of the biggest values and biggest benefits is you get this standardized packaging mechanism. What I run in my Docker image, which is which translates to a Docker container, when I run it, that's going to be the same that runs in production. The only difference is if I'm talking to a database, if I'm pulling secrets, those are environment specific. And obviously those will be different based on your environment. So you have this standardized way of testing, of packaging your software, that you don't have to worry about oh, it worked on mine, but it's not working in production.
Yeah.
Right.
It's pretty great. I mean, it solves so many problems, like you said, of sort of throw it over the wall. Well, now you can know that the wall doesn't change, what's on one side versus the other. You have a Linux kernel and you have the Docker daemon, and that's all you need, right?
Yeah.
So, like you said, some of the environment specific things might be set, but those are all set using environment variables, and so you can easily change those and inject them.
Yeah, and ultimately, this is just giving you it. With this comes, I would say, speed, because now when I want to scale containers share the operating system, right? They're sharing the kernel, the low-level kernel. So they basically, to put it simply, they're carving out resources that they need to run these containers. This is what containerd Docker is doing. And so to spin up a new container is very quick. Whereas when you launch a virtual machine, there's the whole boot process, right? Like there is an order of operations that has to happen every time a new virtual machine comes up. You can't avoid that. So, and then I would say just one of the other huge benefits is just security. You have this isolation. I don't have to think anymore about, creating all these different users on the host, managing users, managing groups. There's a lot of complexity that comes with that.
Yeah, everything gets dropped into its own sort of sub environment, so to speak. Its own, think of it like a cheroot jail, and executed from there. So yeah, there's definitely a benefit.
So here's what we're going to do. We're going to build a container image, and then we're going to run that container, and we're going to approach it in two ways. So before we can migrate our application, we need to containerize it. Okay, so the first path we're going to look at is cloud native build packs. So if you haven't heard of build packs, the documentation is linked here in the workshop. But this is basically an open source tooling. And a build pack is a way, if you don't understand Docker files, you don't understand containers just yet, container images and all that goes with it, you can use build packs to simply say, to build a Docker image for you without you having to know anything about it, what a Docker image is. Essentially, you define what's called a proc file. And this proc file is simply saying, here's how my code runs. So for my code here, we basically, if we were to go to, let me show you what my proc file looks like. Go to app, and we get proc file. I'm saying that the way my application runs is I just run this, python3 main.py. Okay, and that is how I run. So that's all you need is here's how my application runs. The build packs now are going to actually figure out what programming language I'm running, what needs to be installed on the host. It's able to derive these things because of basic kind of common practices within each programming language. Go has a standardized way of building and developing. Python has a standardized way, and so on. So it's actually figuring that out for you and then building the image.
Yeah. So you may not need to use build packs, but if you're asking the question, how do I build a container? Build packs is really a good place to start. It may not even be where you stay, but a lot of people start here and stay here, and they just continue to use build packs to build their container. And in the end, could you optimize it and build a slightly more efficient container? Quite possibly, but is it worth the effort? Maybe not. So it's totally up to you. If you already know how to build a Docker file and build an image from that Docker file, then maybe you don't need to worry about build packs. But I kind of like them, so it's worth mentioning in this particular context because I think it can help you get to the next step very easily.
Absolutely. And so in order to start with build packs, you're going to install the pack CLI, and just go to Linux, script install, and then just copy the script and paste. obviously, again, this is a Cloud9 instance. It's a test instance. Always, when you pull something down from the internet, know what you're pulling down and piping to bash.
Yeah.
Okay. So I installed the Pack CLI. I set my default builder. So a builder is essentially a Docker image that build packs are going to use to build your image. So it's got all the tools built in that it needs to use to build and package your artifacts and give you that container image at the end of the day. So we're just going to set a default builder. We're going to use this image. And then I'm going to just run pack build. Oh, did I not set?
I think you skipped that command. Yeah.
Oops. Thank you. So we're going to set that. Okay. So now we have our default builder. And then we are going to, you know what? This may be, I think, so if you experience that too, just CD to this directory first and then run this command. I think that may be a bug I just discovered here.
Oh, I think you just didn't run the command.
Okay. I thought I did, but I don't know. So, okay. So I ran pack build user API and I ran it in my app directory. So remember, I just have my proc file, which says my app is run by running Python 3 main py, and I have my code. And I have a requirements text file, which defines all of my packages that I need for my application to run. And this is going to build it for me. So this is going to build my image. And you can see it's installing some packages and doing a bunch of stuff behind the scenes here. So as Brent was saying, I mean, build packs are a great way that if you just don't want to be involved in running Docker build yourself and managing a Docker image, which in my opinion, I think Docker images are pretty simple to understand. The language is very user-friendly. But if you just want to skip that, build packs are a great starting point and a great way to go. So you can see it's building our image, and then at some point here, we're going to have this image, and the image name is going to be user API. And what we'll do just to confirm that it works is we are going to Docker run this image now. Okay, so we'll copy this command here. And so what I'm doing is Docker run. I'm passing in the table. We've created the Dynamo table. You don't have to do this, but since we have a test environment, I want to confirm that my container can talk to the test environments database, which again, we talked about this, right? If this was a production environment, this would be users table production or prod. So that's how you separate your environments for your artifacts. So, okay, we're running our container. So if I do a Docker PS, I can see I have my user API running. Let's curl localhost 8080/health. And there you go. So we've now run this application. We're running it on a virtual machine in EC2. We ran it locally on this virtual machine for our IDE, and now it's running as a container. So we've containerized our application. So congratulations, we're almost there. So,
and let's acknowledge it's not always this easy, but these are the basic steps that you have to follow. And what can sometimes make it harder is figuring out how, all of the environment variables that you need to set. Here we have one, but it's not uncommon to have 15 or 20. And if you own the application and it's an old application, the old style of writing might have had you read in from a config file all of the config settings that you need. And the new style is, well, read that out of your environment. So you'd either have to refactor your app to go to reading settings from your environment, or you'd have to have some kind of bootstrap script that might template out a config file on launch based on environment variables. So these are some options that you'll have to work through. it's very, very dependent on your particular application. But we just wanted you to see, the taste of how this stuff works and how it fits together. And yeah, it's obviously going to be a little bit more involved in real life.
Yeah, absolutely. And by the way, this is also a great way to, if you want to break up a monolithic application, you carve out a chunk, and this user API, this is kind of a similar process too, where I'm just carving out a chunk of our application, containerizing it. And, if you work in smaller chunks, you look at like the strangler method, where I just slowly strangle that monolith until it's nothing, and just break it out into small microservices.
Yeah.
This is kind of similar to that process as well. Okay, so we checked the logs. Everything was great. We ran it locally. But now I want to have a little more control over how we build and control our images. So I've stopped that Docker container running. And now I want to use native Docker tooling. So at this point, we're going to start with building a Docker file. So I'm not going to read this to you, but I will say a Docker file is a very, in my opinion, it's a simple way to define a set of instructions as to how you want to build your container, build your container image, and then how you want it to run when it starts up and when it runs. So we have an example Docker file here. Okay, and by the way, your Docker file, this is your set of instructions. This is where you're going to be working when, if you need to make a change to the operating system or a change to a package you're installing or doing something a little different. This is where you'll make those changes. So let's copy this, and then we're just going to paste it here in the terminal. Make sure you're still in that app directory. And here's our Docker file.
Yeah, so this we would use instead of build packs if we wanted to sort of manage it ourselves. But can you talk just real briefly at sort of the top-down layered approach for this file?
Absolutely, yeah. So it all starts with the from. Okay, you have to have a from, and this is your base image. So what I'm doing is I'm creating my first layer here, which is, this is the base layer, base operating system that I want to run my code on top of, right? This is going to define the image and what I build on top of it. So the beautiful thing about Docker is I can pull down a Debian image. I can make that thing gigantic, gigs. It can be like the old days, right? Like an ISO file, for my operating system. Or I can have more scoped images. So you see here, I'm pulling a Python 3.7 image. So what's happening here is I'm pulling an image. By the way, this is from an upstream image repository. So I'm using Amazon ECR public. And this image has Python 3.7 installed, and it's very scoped to Python and nothing else. So like, I'm not going to find Java on here. I'm not going to find Maven. There's a Maven image if I'm building Java apps. And so that's the point, is you can find very specific images, so you don't have to install a lot of fluff, basically. Then we expose, so we're saying here's our port that we want to run on, and then our health check. So really important that always to have a health check built and defined for your application. And Brent and I will talk about this a lot too, is don't have a health check that checks your database and all these other resources that you're dependent on. The health check should make sure that your application is healthy, not the entire environment. That's what your monitoring's for outside of this, because you can run into some problems there. So I'm going to move along because I want to make sure we have time.
Yeah, sorry.
I'm setting our work directory here. And the idea is I just want to work in a specific directory. So when I install packages, I copy files. It's all just in this one work directory, so I know where to go. So, and then I'm copying these files. So locally on my file system, these are the files I want to live in this directory. And then there's a run command. So the run command is basically just going to run whatever it is I want as if it was running in a live container, right? So it's going to run this pip install, which is going to install my packages into the image, and then the CMD. So this is basically when my container starts up, what are we going to run when the container starts? And so this is running Python 3 main py. That's it.
Yeah. So you could think of this as a start. The from is the equivalent of like the starting server image or something like that. And then all the commands that you might need to run on that server to get it ready to run your application. And then we end with how do you run the application? So it's super simple, super straightforward. If you know how to shell script, even at a most basic level, then you know how to write a Docker file. So it's just a matter of sort of putting those things together.
Yeah, and it's just super, very, very plain text, easy to understand. That's just my favorite thing about it. I don't have to learn some new programming language or anything. It's just, it's not a DSL. I guess maybe it is, right? But I don't know.
It is, but it's so basic.
It's super basic, right? Okay, so I ran a Docker build command. So earlier with build packs, I used their CLI. Now to build my image, I'm just simply saying Docker build, here's my image, and then here's the tag. So tagging your images are important. That's how you can tell. It's basically tagging your image as an artifact, and you are able to reference, when things go wrong or just knowing what's deployed. You use tags for that purpose. If I did the same thing, I'm running this app, and if I just want to quickly, so just like we did with build packs, there you go. So now I've built the Docker image in two ways, using build packs and using the Docker CLI with a Docker file. So really, it just depends on your preference and what you prefer. So at this point, we're going to Docker stop user API. Is it user API? That's the one. We're now ready. We have an image built. I'm confident. I'm ready to get this up and running.
Let's do this.
So this is probably the hardest part for someone who doesn't understand or know containers, container orchestrators, who's never worked with it, I should say. Not, if you're new to this can feel like a very daunting, task. And there's a steep learning curve because you have to understand, how do I orchestrate my containers? And, when we think of a container orchestrator, look at an orchestrator as a way to glue a lot of the logic of scaling your containers, ensuring your containers are up and running, managing them, making sure that they're doing what you expect them to do. That's the job of an orchestrator. And I've used this analogy before. Look at it like a conductor. A conductor is conducting the orchestra, and they are following the conductor's lead. So that is exactly what's happening with the container orchestrator. And the one we're going to use today is Amazon ECS. So just, they're super powerful, but I quickly want to talk about three high-level benefits. Service auto-scaling, the ability to have auto-scaling built into the orchestrator. So I just tell it, these are the metrics, and then here's when I want to scale in and out. The orchestrator's job is to monitor that and then do the scaling accordingly. Health checks are built in, and then logging and monitoring. So I can have logging and monitoring. I can use the orchestrator. ECS will help me with the integrations with Amazon CloudWatch for logging and metrics and so on. So we're going to use the AWS Copilot CLI to get us up and running very quickly. And when I say up and running very quickly, I say that with the confidence that you're doing this not just quickly, but you're doing it in a production-ready way. So this is building an environment that's based off of AWS recommended practices, that's going to give you the scalability, the speed, all the things that you would need, all built into this opinionated tool. And it starts with defining our application. So with Copilot, you have the concept of an application. Look at this as like the kind of the skeleton of your environment. So, we talk about look at it in terms of kind of like a service-oriented architecture, multiple parts and so on. So we're going to name the app. We're running low on time, so I just want to make sure I get through this. Boy, see, Brent, we talk so much.
I know, it's my fault. I drag things out and tell stories and all that.
It's okay. It's the fun part of the workshop. So what I'm doing is I'm creating this application. This is not going to create any resources yet, but what it's doing is it's creating some of the boilerplate. It will create an S3 bucket, CloudFormation template, KMS key, so which it'll use to encrypt certain pieces of resources within our application. But this is going to build that skeleton of our project. The next step with Copilot is we have to define our environment. And when we talk about an environment, this is where we have our network, DNS, basically our ECS cluster, security groups, all these things that we talked about earlier, VPC networking. Copilot will actually build a lot of this for us. But we have the option, and in this case, for this migration, I want to keep our application. I want to stay in the same VPC. So what I'm going to do is I'm going to query our existing VPC, and I'm going to initialize a Copilot environment using that existing VPC. Copilot, by the way, can also create a VPC for me, like I said. But in this example, I want to operate in the same VPC because I want to be able to resolve the service discovery namespace, DNS, in that VPC for my other applications in my legacy environment.
Nice. And yeah, I mean, this is going to be pretty common. A lot of people that are migrating, they don't necessarily want to build a completely new, VPC from the ground up because they might have direct connects, terminating into this VPC. They might have existing stuff, right? Because you're migrating, your app already exists and lives. It has a home. So you don't necessarily want to build it a whole new home. You just want to change the way it launches.
Yeah. And if you are on a team where you don't have a central team that builds and manages VPCs, or you don't have to worry about an existing VPC, I would say let Copilot build the VPC for you, because Copilot's going to do it. Recommended practices. It has all of that built in. So this will take a few minutes, and what's happening is it's essentially creating our boilerplate and going to build our environment, which is our ECS cluster and all those things I mentioned earlier, so we can actually deploy our container to a real world environment. So that's what's happening. This takes a couple minutes. Are there any questions while we wait for this, Brent?
Yeah, I've been answering a couple, but let's call them out anyway. The most recent one is, does Copilot work for EKS2? And I pointed out that no, it's specific to ECS and App Runner. And we're not really talking about App Runner today, but it's definitely something you might want to check out for any of your new applications that are request-based. It's designed for that specifically, and even easier to get started than what we're doing today with our application. But for legacy apps, even legacy apps that are request-based, I'm guessing Copilot into ECS and Fargate is probably the path that you'll want for today. Then there was a little bit of a discussion about Pack, and did it generate the Docker file, or did we do it as part of the workshop? And fact is, we did it. There was a step I answered where we build that Docker file for you. But I kind of, in the back of my mind, I'm remembering that there is a Pack command or option for it to spit out a Docker file. I'm just not sure. So that's something that's probably worth exploring, because it could be interesting to see what does it come up with.
Yeah, it's a good point. I don't know off the top of my head that.
Yeah, frankly, when I use Pack, I don't bother building a Docker file with it, because that's kind of half the reason you're using it, is so that it can manage all that for you. Lots of questions about the recorded session. Is there going to be a video on demand of this? And yes, there is. And another thing to say about that, I mean, we've answered all of those questions, but another thing to say is we're also going to go back and embed this video into the workshop, so that you'll be able to see it, watch it from there. And it'll be a few days, so everyone here on the stream gets an advanced access.
Signed copy.
That's right.
So, okay, let me just jump back in. So our environment created. And again, you can see here, Copilot, one of the really great things about Copilot is it's a guided experience. You can override the guided experience by passing in command line flags. But I like to use the guided experience because every time, if there's an update to it or something, I can take advantage of the latest functionality. But it also helps get me to where I need to go much quicker. So it created an ECS cluster, some Iam roles, security groups, all these things. We like to call them boilerplate, things that I don't want to deal with. So the next step is I'm going to create a Copilot service. Now the service is what's responsible for running my application or that container image, right, that we built earlier. So this is the guided experience. Copilot's going to ask me what type of service do I want to build. I want to build a backend service. I don't need a load balancer. I just want it to run in a private subnet so other instances, services can talk to it. We're going to name it user API. It recognizes I have a Docker file, but it also gives me the option if I want to point to an upstream image or a custom location, I can do that as well. Notice it created a manifest for me. So earlier with the CDK, when I showed you I was building a lot of stuff with code. With Copilot, I just have a simple manifest YAML file, and it's really simple. And what we're going to do is, so it created this kind of skeleton of our service, okay? Now what we need to do is we need to add some overrides here, okay? But one thing to notice is if you look at that manifest file, you cat it, you'll see there's a port here. Did I define port anywhere, Brent?
No, not that I saw.
There's a health check. Did I define health check anywhere in there?
No.
I didn't. And that's because Copilot actually introspected my Docker file. And it saw that I have an expose statement and I have a health check statement, and it popped those into the manifest. And when I deploy my service, that's going to be built in out of the box, ready to go. So there's a couple more things we have to do, and we have a few minutes, so I want to get through them. We need to make sure that our service can talk to DynamoDB. So one question we get asked a lot with Copilot is, what happens when I need to build something that Copilot doesn't manage or that doesn't build in an opinionated way? This is where add-ons come in. So using CloudFormation, I can actually create resources using CloudFormation templates with Copilot. So what I'm going to do is I'm going to create an add-ons directory, and I'm going to add this IAM policy in there. This IAM policy is going to give me the permission I need to talk to that Dynamo database. And notice these are parameters that are passed in, the app name, environment name, and so on. So my resource name is actually dynamic, and it's users table env. And you saw it was users table test. So if I have a prod and so on, I can dynamically do that. So we created this IAM policy. Copilot's going to automatically attach this policy to my task at runtime. So when it builds this, it's automatically going to do the creating the policy the first time and then attaching it to my resources. The next step is I want to pass in a security group to my service because, again, we're in the same VPC, and what we're doing in this security group is we're allowing any other host that has this security group attached to it can talk to any other host that has this security group attached to it on port 8080. So what I'm doing here is two things. I'm passing an environment variable. Remember, our app looks at the Dynamo table from an environment variable, and I'm also passing in the security group to attach to my task. Okay, so you can overwrite environments here. So I have test, I could have a production staging, and I could have environment-specific overrides for anything in the manifest file. So the last thing I'm going to do is I'll keep the count for now, but you could do this on your own, which this would build in auto scaling. I can literally say, here's the range of tasks I want to run. And here's the scaling metric that I want you to scale at. So for 3 data points, if you're at or above 50% CPU utilization on average for all my tasks, scale up. Like I don't have to build anything else. So let's deploy it. And again, I'm sorry that I'm moving fast here. But again, we've written a lot of content in here that you can walk through, afterwards as well. But what's happening now is Copilot is going to build a service, an ECS service. So think of an ECS service as a way for the scheduler or the orchestrator to ensure that our desired state for that service is always met. So that means you're running this container, you're exposing it on this port, and that it always registers with a service discovery namespace, which, by the way, service discovery is built in. I didn't even talk about building something for service discovery. That's just built into the tool and the service.
That's pretty cool. And in our particular example, we don't necessarily need service discovery yet, but in a real life example where there's another application talking to this, service discovery is how that would happen.
And Brent, we are going to use service discovery here.
Oh,
because I deployed it in the same VPC. So what's happening is Copilot's creating this service discovery namespace. It's a private Route 53 hosted zone.
Mm-hmm.
Our existing applications, I'm going to exec into that host, and we're going to be able to talk to our container.
Oh, nice.
Through service discovery on that port.
Nice.
As I attach the security group and all that. So again, from a migration perspective, think about it. I'm running my app on EC2 and I'm running it in the container. I can flip the switch and I can just start talking to my container without having to do anything except switch DNS. So right now it's creating all of those resources. It's creating the IAM policy, the service, and so on. And in another minute or two, what we're going to have is our service is going to be up and running and ready to go. And I know what we're going to have some time for Q&A. So
right.
What may happen is we may do live Q&A, and I may just jump back and really quickly show you. The last thing I want to do is I want to go into that EC2 host where the legacy environment is, and I'm going to show you that we can talk to our new application in that same VPC. It's now running on a container, and our existing applications can talk to that.
Nice.
From there. So
awesome. So should we do a little bit of Q&A?
Let's do it.
All right. Remember if there's a special screen for that or not, but if you have any questions, go ahead and throw them in chat, just like you have been. And in the meantime, I'm going to scroll back and let's just touch on a couple of questions that have come in. Sorry, I'm scrolling, looking for a good example.
No, it's okay. While you do that, so you can see here, our service is deploying. And, oh boy, there we go. So our service is deploying. You can see we have a desired task count of 1. And it's pending. So Copilot is not just a tool to build and deploy everything. It's also a tool to, in real time, get logs, metrics, details about my service as well.
Yeah, we call that day 2 operations, stuff
Yes.
that once it's running, you'll want to be able to do. And I love that you have this screen up because one of the questions that came in was, you spoke about faster boot times for containers. Does spinning containers on Fargate result in faster or slower boot time compared to using an ECS host, or is there no difference? And I answered this to the asker, but let's just throw it out there to the stream. Fargate, the difference in ECS using an EC2 host and ECS using Fargate is basically that there is no EC2 host in the Fargate example. But what that means is some of the resources that your container needs aren't available when we say launch. So when we say launch and the target is going to be EC2, those resources are sitting there waiting, and they're available, and so it's really fast to bring a container up. But in this example, what we just brought up, it came up on Fargate, and you can see it's kind of weird scrolly because of
zoomed in. Sorry.
Yeah, because of the zoom, which is fine, but you can see that it times out every single step to show you how long it actually took. And bringing up the one copy took 68.4 seconds.
Yeah.
So I mean, that's not bad. When in the grand scheme of things, once you have this working and in place, and you're just doing the next version of your deploy, you aren't going to sit there and watch it. It's just going to happen, and you're only going to notice, that, hey, you're on the next version at some point later in the day, right? So that's 68 seconds versus 2 to 4 seconds probably in the case of an ECS host. For me, it's worth the trade-off to not have to manage the ECS host. That's the big trade-off.
Yeah, and we talked about patching, and with the previous example, right? I'm managing an EC2 instance for my other application. If I'm running my containers on EC2 hosts, I have to still be cognizant of scaling as well as patching and managing those hosts. Now, we do have ways with Amazon ECS, with capacity providers, with managed cluster auto scaling. But I would still, if Fargate works for your use case, 10 out of 10, I'm saying use Fargate.
So another question came in. The manifest had a field to scale if the CPU goes above 50%. Once the number of tasks increases, do they stay at the same number, or do they scale down when the CPU utilization goes below 50%? And
yes,
I'll take a stab at this one, but you've been talking a lot. But this sets up something called target tracking auto scaling. And target tracking is the accumulation of all of the running instances. We want them to all target 50% utilization. So it's going to scale up or down to try and make all of the instances achieve that 50% utilization, because we don't want underutilized instances either, right? We don't want everything to be sitting there at 2% utilization, because that's a waste. But we also don't want things to be at 99% utilization, because that's a clear sign that we should be like ready to take on more. So that 50% is a target that we try to achieve within a certain set of boundaries. So that 1 to 10, 1 is the minimum, 10 is the maximum. So it'll scale up and down to try and hit 50% the best way it can. And then another question, service discovery within the same VPC is not automatic, correct? And what do I think this leads into what you want to show us.
Well, yeah. So, okay. So it's created this private Route 53 hosted zone, and this is through CloudMap. CloudMap is our service discovery service. And now, so what I've done is I've exec into our EC2 host where our original application was running. Let's pretend that on this host, I also had another application that was talking on localhost to this app, okay, or whatever. It was talking to our API service. So this is an example now of our hosted zone. We're in the same VPC, but now it's resolving our service discovery service. So it's user API.migrationdemo.local 8080. And you can see there it is. It resolved that host. So
yeah,
in the VPC, now again, it depends. If your VPC has custom resolvers or you're resolving in different ways, it may not work like this, right? So this is why in the workshop, we actually highlight, like, one of the considerations for migration is DNS. You have to think about, how do we talk to our services? So that's just something to consider. And
I think there is a way for you to set an upstream resolver for Route 53. I'm not check with your Route 53 team, but I believe there's a way for you to set an upstream custom resolver so that you can put Route 53 in the middle, and that can take care of service discovery for you. And meanwhile, anything that doesn't match up would then go on to your upstream resolver.
But so just to answer that question specifically to the workshop, I didn't do anything to enable like that discovery. That was just, I used the default VPC configuration within the CDK, and so it was.
And then Copilot set it up for this particular service.
Yeah, exactly. Yeah.
Nice. Awesome. If there are any more questions, we have a couple more minutes. Otherwise, I think we might have, you know, a poll at the end that we want to make sure to gather your feedback. If you've liked this content and you want to see more like it, then you can find Adam and me at containersfromthecouch.com. We have a YouTube channel, and it's not always just us. We bring on a lot of guests, but we talk about running containers. We talk about ECS, EKS, App Runner. We talk about all kinds of stuff. So definitely check that out. Again, it's containersfromthecouch.com. And then obviously you can find this workshop and all the content, as we've mentioned before, at ecsworkshop.com. So, and then if you can get on any one of these, you'll find links to all the others. Down at the bottom of this page is a link to Containers from the Couch, as well as some of our other workshops that we have. You can also find our Twitter handles there, so feel free to reach out if you have any questions or anything that you want to give us feedback on. We're happy to listen. So yes. We've had a good time with this, and I want to make sure that we get your input at the end. So we're going to go to
one more thing.
Oh, yes, go ahead.
Cleanup. So when you're done with this, please make sure you walk through the cleanup steps. The last thing I want is for you to pay for resources that you're not using and get a surprise bill for something. It wouldn't be anything crazy, but anyways, just run through these cleanup steps when you're done. And then one last thing is just that day 2 stuff. You can see a Copilot service status. I can see my service is healthy, how many tasks are running. If I have auto scaling, I can see the alarms. And then the last thing is I just want to show you Copilot service logs. I can actually follow the logs too in real time. So Copilot is a tool to build and manage our environments. And it's also that day 2 tool to have the insight into our environments, troubleshooting, and so on. So that's my spiel. Don't forget to do the cleanup. But again, thank you everybody so much. It was a great time. And please reach out to us on Twitter if you have any questions or you would just want to chat. Brent and I love to chat about containers or anything on AWS for that matter.